You take any crazy idea. I don't know, it's hard to make up a very crazy one thing, witches or something like that, and you tell about what people used to believe in witches, and of course nobody believes in witches now, and you think, how could they believe in witches? Then you turn it around and you say, let's see, what witches do we believe in now? What ceremonies do we do? Every morning we brush our teeth. What is the evidence that the brushing the teeth does us any good in cavities? So you start wondering, are we all, imagine as the Earth turns on the orbit, there's an edge between light and dark. And along that edge, all the people along that edge were doing the same ritual for no good reason. Just like in the Middle Ages, they had other rituals. And you try to picture this perpetual line of toothbrushes going around the Earth. It's to take the world from another point of view.
The most enduring legacy from his father was not just learning to question the physical world, but an enthusiasm for the inquiry, which at 54 Feynman still shares today.
It has to do with curiosity. It has to do with people wondering what makes something do something. And then to discover that if you try to get answers, that they're related to each other. That things that make the wind make the waves, and the motion of water is like the motion of air, is like the motion of sand. The fact that things have common features turns out more and more universal. What we're looking for is how everything works, and how everything is, what makes everything work. And what happens first in the history is we discover the things that are on the face of it obvious. And then gradually that we ask more questions, and then we dig in a little deeper to things that we can just make. We need to do a little more complicated experiment to find out about it. But it's curiosity as to where we are, what we are. The world is strange. The whole universe is very strange. But see, when you look at the details and you find out that the rules are very simple of the game, the mechanical rules by which you can figure out exactly what's going to happen when the situation is simple. It's again this chess game business. If you were in just a corner where only a few pieces are involved, you can work out exactly what should happen. And you can always do that when there's only a few pieces. And so you know you understand it. And yet, in the real game, it's so many pieces you can't figure out what's going to happen. So there was a kind of hierarchy of different complexities. It's hard to believe. It's incredible. In fact, most people don't believe that the behavior of, say, me, one yak, and you nodding and all this stuff is the result of lots and lots of atoms all obeying these very simple rules. Come out that it evolves into such a creature that the billion years of life with its experiences has produced the thing with prongs that stick out like this and so on. There's such a lot in the world, there's so much distance between the fundamental rules and the final phenomena that it's almost unbelievable that the final variety of phenomena can come from such a steady operation of such simple rules.